From this data, we've seen that the ratio between mass and volume is constant for each material. Material A has a constant ratio of mass to volume of 1 gram per 10 centimeters cubed. In other words, 0.1 gram per centimeter cubed. B has a constant ratio of mass to volume of 1 gram per 20 centimeter cubed. In other words, 0.05 grams per centimeter cubed. Now let's plot this data graphically. You are going to need to plot two sets of data. So use one color for material A and another color for material B. Draw one trend line for A and a different trend line for B, but you can do it on the same set of axes, volume on the x-axis and mass in grams on the y. Pause the movie while you do that plotting. This is what you should have found. As you can see, the relationship between mass and volume is direct proportion for each of the two materials. That's why you get a straight line graph. There is a constant gradient. The gradient stays the same all the time for each of the materials. What is that gradient? Gradient is rise over run. Let's calculate the gradient for each of these lines. So to calculate a gradient, you need a triangle within the graph. Any triangle will give you the same answer within a certain line, if it's a straight line. Let's just take the biggest triangle in each case. For material A, we can see that the slope is steeper than B, so the answer of the gradient is going to be greater than B's gradient. Rise over run. Rise, change in y, 5 minus 0 grams equals 5 grams. Run, change in volume, 50 minus 0 centimeters cubed equals 50 centimeters cubed. Gradient, 5 grams per 50 centimeters cubed, 1 gram per 10 centimeters cubed. In other words, 0.1 gram per every centimeter cubed. This is the same value that we found for the density of material A, the ratio of mass to volume. It's a constant for this particular substance, material A. What about the gradient for the graph of material B? Rise over run. Let's take the biggest triangle. Change in y, 5 minus 0 grams, divide by change in x, 100 minus 0 centimeters cubed. 5 grams per 100 centimeter cubed is equal to 1 gram per 20 centimeter cubed, which is 0.05 grams for every centimeter cubed. 0.05 grams per centimeter cubed. Just want to quickly demonstrate that you don't have to take that biggest triangle. Any triangle within that graph will give you the same value because there's a straight line, so the slope is the same all the time. So let's take the smaller triangle over here for material B. Rise now is 5 minus 2 grams equals 3 grams. Run is 100 minus 40 centimeters cubed, 60 centimeters cubed. So we now have 3 grams per 60 centimeters cubed, which is 1 gram per 20 centimeters cubed. Again, 0.05 grams per centimeter cubed. It doesn't matter what triangle you take. Within that same straight line, you will always find the rise over run, the gradient. In other words, the ratio of mass to volume, a constant value, which is the density of that particular material.